Hi, welcome to Pre-Algebra, Lesson 10-4, Solve Problems Using Angle Relationships. In this lesson, we'll be able to solve problems involving angle relationships. So let's look at Explore It. The intersecting skis form four angles, as you can see over here. We have angle 1 over here when we crisscross the ski, right? And then 2 where the person is, and then angle 3 over here, and then 4 over here. So list all the pairs of angles that share a ray. So do you know what a ray is? A ray. It is a line where it has a direction going towards something. It has an endpoint and then it has a direction. Okay, so what are the angles that share a ray? So this is one ray. So this ray is shared by angles 2 and 3. This ray shared by angles 1 and 2, right? So we're just gonna list these pairs. So in order to write angles, you're going to write angle in this notation, angle 1 and angle 2 and angle 2 and angle 3, and then this ray is shared by angle 3 and angle 4, and then we have the last ray that is shared by angle 1 and angle 4. Okay, and that's it. So part B, suppose the measure of angle 1 increases. What happens to the size of angle 2 and angle 3? So suppose this angle increases like this. But then this is one ski, right? So one line that goes both directions. Line is a line that goes both directions. So what happens to the other angles? Angle 2 becomes smaller, right? It goes that way. So 2 gets smaller, and the angle 3 also gets larger, like angle 1. So angle 2 decreases, and angle 3 increases. So let's look at part C. How does the sum of measures 1 and 2 change when one ski moves? So if this one ski moves, measures of 1 and 2 will change accordingly, but they still form 180 degrees, right? The sum would not change, but then the sizes would change according to what the other angle is, right? So they're called complementary, supplementary angles. Complementary angles are for 90 degrees. So supplementary angles is what they're called. That is a vocab word you should know. So let's first write the explanation part, and I'll talk about the vocab a little bit. The sum of the angle measures would not change because why? Because as angle 1 increases in size, the size of angle 2 decreases by the same amount, right? So they are called supplementary angles when their sum is 180. When the sum, so supplementary make a sum of 180 degrees. So there's a word called complementary angles when the sum would be 90 degrees. Okay, so vocab word. Let's look at focus on math practices. Why does the sum of all four angle measures stay the same when one of the skis moves? Why do all these sums stay the same no matter how the skis move? Because that's like the biggest angle you can have for a circle, right? Yeah. So as one angle grows larger, the other angle next to it grows similar. if we're talking about like two dimensions, right? So let's start writing that. As one angle grows larger, the angle next to it grows smaller by the same amount. So that the sum of those angles remains the same. So the four angles are connected so that if one angle changes, the others change as well, and the sum of all four remains the same as 360 degrees, right? Okay, so that was an intro to angle relationships. Let's move on to example 1. So the essential question for this lesson would be, how are angles formed by intersecting lines related? So example 1, solve problems involving adjacent and vertical angles. Adjacent, first of all, means the angles are right next to each other, like they're right next to each other. And vertical angles are the angles that are not touching, so like the opposite angles. Okay, so adjacent would be like A and B, B and C, and then C and D, and so on, right? Wait, those are not angles. So if we say this is 1, 2, 3, 4, we can say angle 1 and 2 are adjacent, 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 1, they're adjacent. And then vertical angles are 1 and 3, right? Opposite angles, and then 2 and 4. So let's look at this example. A skewed intersection has two roads that intersect at more than 20 degrees away from 90 degrees. What does that mean, right? Determine whether the road intersection shown is skewed by finding the measures of angle ABC and angle DBE. So, intersection that has two roads that intersect at more than 20 degrees away from 90 degrees. So 90 degrees is this, right? Right angle. It's more than 20 degrees away from 90. So this part is more than 20 degrees away. So 90 minus 20 would be 70, right? So this angle must be smaller than 70 or equal to, smaller than 70. It cannot be equal to because it's more than. And then this angle must be bigger than 90 plus 20, which is 110. All right, so the measures of ABC and DBE, so 1 and 3 angle over here, are expressed as x plus 35 and 2x minus 10. But then they're vertical angles, so they're actually going to be the same angle. So the angles are related like this. The vertical angles have equal measures, because if these are two lines, right, and this line moves, that line moves from here to that, this line also moves the same way, right? So then the vertical angles will have equal angles. And the non-overlapping angles that are array called adjacent angles, like right next to each other. So yeah, they're supplementary angles, and we can talk about that again. Write and solve an equation. Because they're equal to each other, we can write an equation. X plus 35 is equal to 2x minus 10. And we know how to solve equations, right? So now we can just solve for x. X is 45. So going back to our angles, if x is 45, then we can just plug in 45 into x and say, okay, this is going to be 45 plus 35. So then it's just going to be 80. And that's also 45 times 2, that's 90 minus 10, so that's also 80. So both of the angles would be 80 degrees. They're within 20 degrees, so the road is not skewed. So if it's only skewed if it's more than 20 degrees away. So let's look at try it. Angle M and Q and angle P and R are vertical angles. What is the value of X? So we know the information that they're vertical angles. This is very important information. We know the vertical angles have the same angle measures. So you can write an equation and figure the lengths out. So pause the video, come back when you're ready for answers. Okay, let's fill in the blank. The vertical angles are equal. So the equation, which equation? This equals to that, right? So 3x minus 6 equals 114 can be used to find x. The value of x is what? You need to solve this equation. So plus 6 on both sides, 3x is equal to 120, and then divide by 3 on both sides. X is equal to 120 divided by 3 is 40. So value of x is 40 degrees. Okay, and that's it. You just need to figure out the values of x. You don't need to figure out this because we already know this angle is going to be the same, 114. Convince me, why can you use an equation when solving for x in the diagram? Why? Because this is written in an expression and we know vertical angles are the same, right? So we can set up an equation to solve for the missing variable x. Simple. So let's write that in words. Because the angles with measures given are vertical angles that have the same measure, you can write an equation to set the given measures equal to one another. Okay, let's go to example 2. Solve problems involving complementary and supplementary angles. Part A, ray EG splits DF into two angles, DEG and GEF. Find the values of x. So these are called complementary angles, as I mentioned in the beginning of this lesson, because they add up to 90 degrees. Supplementary angles have a sum of 180 degrees. So if we have the information, we can set up an equation using the given expressions, right? So we know that angle DG is 3x and angle GF is 36 degrees. So then we can say, okay, 3x plus 36 must be 90 degrees because we know they're complementary angles. And we have an equation. We can solve an equation. X is 18. So that's it. We found the values of x. And you can just check if these angles, if you plug in this x, if these angles would have a sum of 90 degrees. Part B is the same thing, but these two angles are supplementary angles, so they add up to 180. So then we can add 50 plus x over 2 minus 4 equals 180. Solve for the x, and that is your equation. That is your value. Okay, let's look at example 3. Find the measure of an unknown angle. So now, let's look at this diagram. There are a lot of different lines, a lot of different angles that we can talk about. But here, this is a right angle sign, right? So we know this angle KAR and this angle RAP are going to be complementary angles. These are complementary angles, right? But then we don't know what this is. We're trying to figure out the values of x, but we don't know what this angle is. But how do we know that angle? This angle would be the same as this angle, right? Well, we don't know that, right? But that's not really important right now. The information we have here is 6x, and that is a vertical angle to this angle. So then we know they're equal to each other. We can just set them equal to each other. Now we have this equation. Solve for x, we have 4, right? We found the values of x. And now we can figure out angle PAR. How? Because now that we know this value, we know this angle has to be a complementary angle to make a 90 degrees with this one, right? So 2 times x, which is 4 now, right? 2 times 4 plus 16 plus this angle, x. Now this is x. Let's use another variable so that it's not confusing. Plus y, let's say this is y, is equal to 100, no, not 100, 90 degrees, right? Or you can use this expression too. Or you can set up an equation using this. 6 times 4 is equal to plus y is equal to 90, because if this is y, that's also y, right? So vertical angles are the same, so that's what you need to know. And you can set up an equation to figure out what the information you want to. So let's look at try it. Measure 1 is 4 times measure 2, angle 2. So angles 1 and 2 are complementary. So this is important information, right? Angles 1 and 3 are vertical angles. 3 and 4 are supplementary. What are the measures of 4 angles? I highly recommend drawing a diagram and solving this out. Pause the video and come back when you're ready for answers. Okay, are we ready? So, what have you come up with? If measure of measure of angle 1 is 4 times measure of angle 2, measure of angle 1 is a lot bigger than angle 2, right? So you're gonna kind of draw a diagram. Draw lines, okay? And 1 and 2 are complementary, which means they add up to 90 degrees. So you draw a 90 degrees angle, and then this is just split into 2 angles. This is measure of angle 2. And then this is measure of angle 1. This is angle 1, right? And then number 1, angle 1 and angle 3 are vertical angles. So then you have 2 lines that are the same. So these 2 lines and these 2 lines are the same, and then this is vertical. So this is measure of angle 3. This is angle 3. And then 3 and 4 are supplementary. So 3 and 4. So yeah, 4 could be this one or this one with including 2, right? So let's say this is 4. Okay, what are the measures of the 4 angles? So first of all, measure of angle 1 is 4 times 2. So let's say this is x, right? So then this is 4x. Then vertical angles are the same, so this also has to be 4x. And then they have to be supplementary, so 4x plus measure of angle 4, let's say y, is equal to 180, right? So first of all, let's write an equation for measure of angles 1 and 2. So we have 4x plus x is equal to 90. Right? And then we have another equation, 4x plus y is equal to 180. Let's solve for x first here. So that's going to be 5x equals 90. X is equal to 90 divided by 5, which is going to be 18. So measure of angle 2 is 18. And then, so let's write that down. Measure of angle 1, we don't know yet. Measure of angle 2 is 18 degrees. So 18 times 4 would be 72. So 4x, so that is 18. This 4x is now 4 times 18, which is 72. So this is 72 degrees. Measure of angle 3 is the same measure of angle 1 because they're vertical angles, so 3 is also 72. Measure of angle 4 is supplementary to angle 3 or angle 1. So that's going to be 72 plus y equals 180, which means y is 180 minus 72, which is 108. So measure of angle 4 is 108. So these are our last answers, final answers. Okay, did you get them right? Check your answers. Let's look at the summary of the lesson. So the key concept of this lesson is that you know what supplementary angles are, vertical angles are, complementary angles are, adjacent angles are, and how they're equal to or how their sum is equal to something, right? So remember, supplementary angles add up to 180 degrees. Complementary angles add up to 90 degrees. Adjacent angles are just right next to each other. Vertical angles are opposite to each other and they have same angle measures. Okay, so just remember these key concepts. That was lesson 10-4, solving problems using angle relationships. Okay, so we'll continue with the next lesson in the next video. Bye!